Finally, we'll look at organization of the periodic table. The first periodic table, as we know it, was created in 1869 by a Russian scientist named Dmitry Mendeleev. On our modern periodic table, we call the columns groups, and there are 18 of them. The groups, remember, are the vertical parts of the periodic table. Knowing what group an element is in will tell you the elements that have similar properties to that particular element, and also lets us know how many valence electrons there are. We learned about 4 particular families on the periodic table. In the first 2 groups, we have our alkali metals and our alkaline earth metals. Both sets of these elements are soft, they are shiny, they are highly reactive. Group 1 is the most extreme reactivity, while group 2 is a little bit less reactive, a little bit less soft, and a little bit less shiny. These 2 groups of elements are very similar to each other. On the opposite side of the periodic table, we have 2 additional families. We have our halogens, group 17. These are highly reactive nonmetals. They like to form salts. They typically have particular colors, and they can be either solid, liquid, or gas at room temperature. Finally, our noble gases in group 18. These are non-reactive gas elements. They don't just have low reactivity, they do not react with anything, and they are always found as a gas in nature. Next, we'll look at our rows on the periodic table. These are called periods. This is how the periodic table was originally arranged. There are 7 periods on our current periodic table. If we added any more elements, we would have to start an 8th period to contain those new elements. Knowing what period an element is in doesn't tell us a whole lot, but it does help us know how many energy levels there'll be in the electron clouds. If you were drawing a Bohr model and wanted to know how many circles to start with, you could count and see which row the element is in, and that will let you know how many circles you need to include or how many energy levels you need for that particular element. Periodic table, this is a very simplified view that we can use to help look at some of the parts. So here on this periodic table, I've highlighted in yellow one example of a group. So remember that the groups are vertical. The groups are also known as columns. Remember that the first 2 and the last 2 of those columns are called families. So those up and down ones are called groups, and there are 18 different groups. If you wanted to number them, starting on the left at number 1, all the way across to number 18 on the right. Then moving down, we have our periods. Our periods are the rows that go across, so there are 7 of those. So if we wanted to name them, we could see that we have 1, we have 2, we have 3, we have 4, 5, 6, and 7. Remember that these 2 bottom sections here are intertransition metals, really properly belong up in rows 6 and 7. They don't get their own rows on the periodic table. If you wanted to label all of these different sections here, remember that these are your alkali metals. These are your alkaline earth metals. This section here in the middle, these are called your transition metals. I'm just going to put a TM. And then this section over here, well, let's do these ones over here first. These are your halogens, and then these are your noble gases. And then I'm going to switch colors here. Let's find our metalloids. Remember that our metalloids are going to be the dividing line for us between the metals and the nonmetals. So we're looking at these 4 elements here, starting with boron, and then these 3 elements underneath, germanium, antimony, and polonium. So these elements that we've highlighted in red, these are what we call our metalloids. I'm just going to put MD for metalloid. And then everything over here to the right of our metalloids, these are our non-metals. And that includes actually hydrogen as well. Remember that hydrogen is considered a non-metal. And then let's just switch colors one more time. Let's do a yellow color. So our metals are going to be all the rest of this whole section here. These are all considered our metals, everything from aluminum down underneath those stairs. These are all considered our metals. Okay, then finally, of those three categories are metals. Some of those properties that we're likely to see, metals tend to be soft, which means they are malleable and ductile. Malleable and ductile mean you can dent or bend or shape it. Remember, metals are soft based on how the material responds to a hammer, not based on how it feels to your fingers. Metals are soft, they are shiny, which means they have luster. Metals tend to be reactive with acids. They also sometimes oxidize in the air. Some of them, like our group 1s and 2s, can also react with things like water. Our nonmetals tend to be hard. This is confusing for a lot of people because a lot of nonmetals, when they are solids, they look more like a powder or a crystalline substance. But remember that if they break apart or shatter or crumble when hit with a hammer, that is considered a hard material according to chemistry. So we consider that to be brittle if it falls apart when you hit it with a hammer. Nonmetals are dull, they do not have luster, and nonmetals are non-reactive with acids. They might react to other things. Remember that halogens are highly reactive nonmetals. They just don't react with acids the way that metals do. Finally, that narrow section, which we call our stair step, those are called metalloids. Metalloids may have a combination of properties. Oftentimes they look like a metal, like the silicon did in our lab. Remember how it was silvery and shiny and it looked metallic? But its behavior was more like a nonmetal. It didn't react to the acid, and it certainly wasn't soft enough to dent it with a hammer. As the pieces break apart, they break apart into sharp, jagged edges. That's not what a metal does. So it behaved like a hard material, but it looked like a shiny material. That's how we know that it's a metalloid.